Hello everyone, today is discuss about BSc first year, that is first semester, paper 1, that is paper name is Mechanics of a Particles. Today is discuss about the topic is rigid body rotational kinetic relations. So kinetic relations discuss cheyadam jarugutundi. So this is rigid bodies topic is rotational motion and rotational kinetic relations and rotations with constant angular acceleration, angular between the translation and rotational kinetic relations, and rotational between linear and angular momentum, and equation of the motion of a rigid rotating body. So these are the discuss about these topics today. So first of all, rigid body. What is the rigid body? So a body which does not undergoes any change, shape or size by the application of external force is called the rigid body. Rigid body means that is any objectives or any body which does not undergoes any change. అంటే మనకి ఎనీ రిజిడ్ బాడీ తీసుకున్నప్పుడు దట్ ఈస్ అప్లైబుల్ టు ది ఎక్స్టర్నల్ ఫోర్స్ అప్లై చేసినా కూడా షేప్లో కానీ సైజులో కానీ ఎలాంటి చేంజెస్ రానట్లయితే దాన్ని రిజిడ్ బాడీ అని అంటాం. ఓకే, ఏ రిజిడ్ బాడీ విచ్ డస్ నాట్ undergoes any change in shape or size by the application of external force is called the rigid body. A rigid body is that body in which the distance between the constituent particles remains constant in all conditions. The particles only minutes oscillations or vibrations about their mean positions. Okay, the motion of a rigid body may be considered as the two types of bodies. So one is the translatory motion and another one is the rotatory motion. Translatory motion is also called the linear motions, and rotational motion is also called as circular motion. Okay, a rigid body is only an ideal concept and cannot be realizing in practice. So here rigid body is the one example. A square shaped scale slide an inclining plane, its motion is purely translational. The motion of a flywheel fixed position is only rotational. So rotational about its own axis. Where sphere roll on the inclined plane, it slides as well as the rotation, and thus its motion is a combination of the two types of the motion. So you know everyone what is the rigid body? Rigid body which does not undergoes any change, shape or size. సో బై ది ఎక్స్టర్నల్ ఫోర్స్, ఎనీ ఆబ్జెక్ట్ మీద ఎక్స్టర్నల్ ఫోర్స్ అప్లై చేసినా కూడా షేప్లో కానీ సైజులో కానీ మనకి ఎటువంటి డిఫరెన్స్ చేంజ్ కానట్లయితే దాన్ని రిజిడ్ బాడీగా కన్సిడర్ చేస్తాం. ఎగ్జాంపుల్గా మనకి ఒక ఐరన్ బాల్ తీసుకున్నప్పుడు దాని మీద ఎక్స్టర్నల్ ఫోర్స్ అప్లై చేసినట్లయితే ఐరన్ బాల్లో కొంత షేప్ అనేది అంటే ఇంటీరియర్ కాకుండా ఎక్స్టర్నల్గా కొంత చేంజ్ అవుతుంది. సో దట్ ఈస్ నాట్ ఏ రిజిడ్ బాడీ, కంప్లీట్ రిజిడ్ బాడీ. రిజిడ్ బాడీ ఈజ్ ద ఓన్లీ అన్ ఐడియల్ కాన్సెప్ట్ and cannot be realized in practice. Okay, so manaki general ga a rigid body is that body in which the distance between the constituent particles remains constant in all the condition, like molecules and gas. These are the particles remains constant in all direction. Okay, the particles only minutes oscillations or vibrations about their mean positions. Okay, these are the rigid body. And rigid body is the motions of two types. So one is the translatory motion and another one is the rotational motion. Translatory motion of is its center of the mass, and rotational motion of the its particle around the center of the mass. That is called the translatory motion and rotatory motion. Rigid body is using only rotatory motion. You know translatory motions already last class lo manam discuss cheskunnamo. Today rigid body is the rotatory motion. Okay, so these are the examples of the rigid body. And another one, rotational kinetic relations. సో ఈ రొటేషనల్ కైనెటిక్ రిలేషన్స్ ఏంది రిజిడ్ బాడీ మీద డిపెండ్ అవుతాయి. లెట్ us కన్సిడర్ దిస్ ఈస్ ద వన్ ఆఫ్ ద రిజిడ్ బాడీ. సో దట్ ఈస్ కన్సిడర్ ఏ రిజిడ్ బాడీ. దిస్ ఈస్ ద rigid body. ఈ rigid body about an axis passing through the center O and perpendicular to this plane, that is OP plane. So this is the XY plane, this is the opposite of the direction, another direction or anti-clockwise. This is the opposite direction of the Z axis. That is the XY plane is perpendicular to the Z axis. A plane of the rigid body that is at a right angle to the axis of the rotation as shown in this figure. So OP is the that is the p is the particle, then x axis is rotated to the anti-clockwise direction, this particle. So that is the displacement of s, and the OP is the distance of the r, that is the position vector, and one particle is x axis to the move to the anti-clockwise direction, that is the displacement. This is the distance of the displacement, that is the symbol of s. Okay, this is angular displacement is s. This is the angle of theta. So to locate this particle we require two coordinates, that is one is the position vector and r, and angular is theta. So for different particle in this plane or the rigid body, values of r and theta will be different. Now kinetic relations is observed. So kinetic relations means angular acceleration, these are all discussed now. This is the kinetic relations of angular displacement. Let us consider angular displacement is the symbol of theta. So let theta be the angle. Here you can observe that this figure, the angle of the theta rotating in x axis to the particle is rotating to the anti-clockwise direction. This is the displacement of the linear displacement is s, and position vector OP is the distance is r, and that is the displacement, and r and s, that is the angle between the theta. So here within time, let us anti-clockwise direction in a time t, let SB is the linear displacement and r is the radius of the circular path. The angular displacement is defined as the ratio of the arc length and radius of particle, that is r. This is the circular path is given by angular displacement theta is equal to s by r. So s is the displacement and r is the radius and position vector also. Theta is equal to s by r. So angular displacement is the units of the radius. Okay, and next one is angular velocity is the symbol of omega. This is the rate of change of the angular displacement is called the angular velocity. So omega is equal to d theta by dt. Angular displacement is the symbol of theta. So you can write d theta by dt. The rate of the change of the angular displacement is called the angular velocity. Omega is equal to d theta by dt. What is the angular velocity? Units is the, that is radius per second. This is the displacement, that is the radius, and within a time. So time is units is seconds. So units of the angular velocity, radius per second. And another one, angular acceleration. This is the symbol of alpha. So that is the rate of the change of the angular velocity, that is called the angular acceleration. Angular acceleration alpha is equal to d omega by dt. So omega is the angular velocity. So that is the d omega by dt. Omega means d theta by dt. You can write omega is equal d theta by dt. So differentiating again, so d square theta by dt square. So angular acceleration alpha is equal to d square theta by d theta square. What is the units of angular acceleration? Radius per second square. So here ikkada t square kabatti, so that is units of seconds square. This is the angular acceleration. Once again explain, that is this is x axis, one is the particle is within a time t seconds after this reach this particle, this is p. So this is the displacement of s, and within an angle of theta, and position vector OP is equal to r distance. So this is the angular displacement theta is equal to s by r, you can write. Okay, so this is the theta equal to s by r, angular displacement, and angular velocity is the rate of the change of the angular displacement is called the angular velocity. Omega is equal to d theta by dt. Again, and angular acceleration is the symbol of alpha. Alpha is equal to the rate of change of the angular velocity is called the angular acceleration, that is d square theta by d theta square, radius per second square. These are the kinematic relations. Okay. So next, rotations with constant angular acceleration. Rotation with constant angular acceleration, the simple type of the rotational motion is that in which the angular acceleration, that is alpha, is equal to 0 or a constant value. If the particle is rotates about the fixed axis with the constant angular acceleration alpha, the equation of motion is a particles is called omega is equal to omega naught plus alpha theta. So theta is equal to omega naught t plus alpha half of 1 by 2 alpha t square, and omega square minus omega naught square is equal to 2 alpha theta. These are the motion of the particle equation. Now we prove that this equation, you know everyone, linear translation and rotatory, this is only axis పరంగా రొటేట్ అవుతూ ఉన్నప్పుడు మనకి యాంగులర్ యాక్సిలరేషన్ కానీ యాంగులర్ వెలాసిటీ కానీ యాంగులర్ డిస్ప్లేస్మెంట్ కానీ ఫైండ్ అవుట్ చేసుకున్నాం. వాటి నుంచి మనకి ఇవన్నీ రిలేషన్స్ అనేటివి ఫామ్ అవ్వడం జరుగుతుంది. సో దీస్ ఈక్వేషన్స్ ఈజ్ మోషన్ ఆఫ్ ది పార్టికల్స్ ఒమేగా ఈజ్ ఈక్వల్ టు ఒమేగా నాట్. నౌ దీస్ ఆర్ ప్రూఫ్ నౌ ఇన్ నెక్స్ట్ స్టెప్. So here omega is equal to angular velocity and omega naught is the initial angular velocity and theta is the displacement and alpha is the angular acceleration. These are the symbols of here. So now we this 1 2 3 equations, now we prove that. First one is we can prove. Now you write the angular acceleration. You know angular acceleration, the rate of change of the angular velocity. Alpha is equal d omega by dt. So you can write d omega is equal to alpha into dt. Both sides integration applying, then now integration of d omega is equal to integration of alpha dt. So you can write differentiating integration is cancelled, that is omega is equal to alpha into with respect to t, that is 1 alpha is the constant and integration of dt, 1 is the different integration value is the t. So plus c1, that is c1 is the integral constant. So he can write now c1 is proof that. So the c1 value is, we can find out that the equivalent of the constant of a integration, that is c1, let omega is equal to omega naught at a time t equal to 0, that is the initial condition. So now we can substitute t is equal 0 and omega equal to omega naught. Now you can write omega is the value is omega naught, alpha into t, t is the, this value is 0 plus c1. Now we prove c1 is equal to omega naught. So c1 value is substituting in this above equation, that is omega is equal to omega naught plus alpha t. Now c1 value is in this equation, right? Omega is equal to omega naught plus alpha theta. So this one is prove that. First equation is omega equal to omega naught plus alpha t, can prove that. And another one, and this equation is proof using angular acceleration formula. And another one, second one. Now second one is proof to obtain the angular displacement theta of the body with respect to OX axis at any instance of time t, we can write in equation 1 differentiating with respect to t. So now this equation omega equal to omega naught plus alpha t, you can write omega is means that is angular velocity is equal to d theta by dt. So d theta by dt you can write is equal to omega naught plus alpha t. So now both sides in dt is multiplication, that is d theta, dt is cancelled and d theta is equal to omega naught dt plus alpha t into d theta. So now both sides integration applying. So integration of d theta is equal to omega naught into integration of dt plus alpha into integration of t into d theta. So now differentiating integration is also cancelled, that is we can write theta. Theta is equal to omega naught into with respect to t. So now here t plus alpha is the constant and t is the integration. Integration of x is equal to x square by 2. You can write in t also. Integration of t is equal to t square by 2 plus c2. c2 is the constant, that is the integral constant. You can find out the c2 value and again this substitute the value and you can get the second equation also. And now c2 is the integral constant. So that a constant of integral c2 value, then can find out, let us consider theta is equal to 0 and at a time t equal to 0. Then c2 value you can find, theta is equal to 0 and theta equal to 0 seconds, you can write this term c2 equal to 0. So now that is theta is equal to omega naught t plus alpha t square by 2, that is the second equation. Okay, so theta is equal to omega naught t plus alpha t square by 2. Now this is the second equation is proof that this is the theta equal to omega naught t plus half alpha t square. Now this is the second proof, omega naught t plus alpha t square by 2. And again third one, Third one is proof. Now we can write alpha is equal to d omega by t. This is the angular acceleration is equal to the rate of change of the angular velocity. So alpha is equal to d omega by dt. So alpha is equal to d omega by dt into, here can write this d omega by dt equal, right, d theta is a cancel, and same value d omega by dt is the value. Here d theta is cancelled, that is d omega by dt. Now d omega by dt into d theta by dt. Here omega is equal to d theta by dt. So now write this d theta by dt equal to omega into d omega by d theta. So now this is d theta is equal to outside elinatlete alpha into d theta is equal to omega into d omega. So now applying the integrations, both side integration applying, alpha into integration of d theta is equal to integration of omega into d omega. So here differentiating integration cancel, that is alpha theta is equal to omega square by 2 plus c3. So here with respect to omega, so that's why omega integration of omega square by 2 plus c3 is the integral constant. Now we find out the c3 value and again substitute the c3 value. So to determine the c3 value, let us consider at t is equal to 0, theta equal to 0 and omega equal to omega naught. So now you can this theta equal to 0 and theta equal to 0, omega equal to omega naught, substitute the above equation. Alpha theta naught ante this is theta is the 0, so this term is 0, and omega is equal to, you can write omega naught. So omega naught square by 2 plus c3 is equal to outside elinatlete minus avutundi. So c3 is equal minus 1 by 2 omega naught square. So now this c3 value substituting in the above equation. So you can write alpha theta is equal to omega naught square by 2 minus 1 by 2 omega naught square. So now this is the 1 by 2 is the common. So you can write half of this is the LCM of 2. So 2 is equal to outside, that is 2 alpha theta equal to omega square minus omega naught square. Here omega square is equal to omega naught square plus 2 alpha theta. You can write omega square equal to omega naught square plus 2 alpha theta. This is the rigid body axis paranga rotate avutunnappudu. So that is the rotational motion lo manaki these are three equation of this motion of the particles. Omega is equal to omega naught alpha t and theta equal to omega naught t plus 1 by 2 alpha t square, and omega square minus omega naught square is equal to 2 alpha theta. These are three equations used in angular acceleration, angular velocity and angular displacement equations is used in three equations is prove that is the omega square minus omega naught square is equal to alpha t theta also. So and next topic is analogues between the translatory and rotational kinetics. You know translatory motions and rotational kinetics. Now rotational kinetics is then axis paranga rotate avutunnappudu oka rigid body ni తీసుకొని axis paranga rotate avutunnappudu manam rotational kinetic values అనేటి find out చేస్తున్నాం. అనదర్ క్లాస్లలో ట్రాన్స్లేటరీ కైనమెటిక్స్ అనేటివి ఆల్రెడీ మనం ప్రూవ్ చేయడం జరిగింది. దట్ ఈజ్ లీనియర్ మోషన్స్, లీనియర్ యాక్సిలరేషన్, లీనియర్ వెలాసిటీ, లీనియర్ డిస్ప్లేస్మెంట్, దీస్ ఆర్ ఆల్ ది ట్రాన్స్లేటరీ kinematics. Now this is relation between the translatory and rotational kinetics. There exists close analogue between the parameters characterizing rotational motion with constant angular acceleration and those of rotational motion with constant angular acceleration of a rigid body. Comparing these two equations, rotational and translationary kinematics of a rigid body. See now these are all proof now. దిస్ ఈస్ వన్ ఒక రిజిడ్ బాడీ పరంగా ఒక యాక్సిస్ పరంగా రొటేట్ అవుతున్నప్పుడు మనకి రొటేషనల్ కైనమెటిక్స్ అనేటివి ఫైండ్ అవుట్ చేయడం జరిగింది. సో రొటేషనల్ మోషన్ ఈజ్ ద సర్క్యులర్ మోషన్ ఈజ్ ఆల్సో అండ్ ట్రాన్స్లేషన్ మోషన్ ఈజ్ ద లీనియర్ మోషన్. సో నౌ rotational kinematics is that is angular velocity, angular acceleration, you know, that is linear velocity and linear acceleration, translatory kinematics. So rotational kinematics, angular acceleration, now we prove that omega is equal to d theta by dt and angular acceleration alpha is equal to d omega by dt, and translatory kinematics is linear velocity v is equal to dx by dt. Now ikkada x is the displacement, so dx by dt. So acceleration, that is a is the symbol of acceleration, is the linear acceleration. A is equal to dv by dt. Now this values is right. Del omega is equal to integration of alpha dt, and del theta is equal to integration of omega into dt. Now linear acceleration, that is del a is equal to integration of a into dt, and del x is equal to integration of v into dt. These are the translatory kinematics. This is the linear velocity, linear acceleration, and rotational kinetics. These are equation, angular velocity, angular acceleration. Now the special cases of the constant angular accelerations and linear accelerations. So alpha is equal to constant and a is equal to constant. This is the linear and this is the angular. So now these are all proof. Now omega is equal to omega naught plus alpha theta, d theta is equal to omega t plus 1 by 2 alpha t square, and omega square is equal to omega naught square minus plus 2 alpha theta. And now these are all linear displacement and linear velocity, and this is v is equal to v naught plus a theta, and x is equal to v naught t plus of a t square, and v square is equal to v naught square plus 2 a x. This is now you can find out the theta value, and now here x is also find out. This is the displacement, angular displacement and linear displacement. Linear displacement x is equal to v naught plus v by 2 into t. So theta is equal to omega naught plus omega by 2 into t. Now this is the circular path, rotatory motion, that is the circular rotation. So axis paranga oka rigid body ane తీసుకున్నప్పుడు axis paranga rotate అవుతున్నట్లయితే, that is angular velocity, angular acceleration, angular displacement. And this is also, you know, everyone, last class lo manamu oka translatory motion, that is linear velocity, linear acceleration and linear displacement values. Okay, these are two comparing these equations. Okay, these are very important formulas. This is compared to, so same equally here, that is the symbol of omega and theta and alpha, and here v and x and a, these are the translatory kinematics. Okay, and next one is relation between the linear and angular kinematic for a particles in a circular motion. You know everyone, the relation between the linear and angular. Now we discuss the linear and angular kinematic relations. Okay, so now this is relation between the linear and angular kinematic. You know this everyone, this is the linear and translationary kinetics and rotational kinematics, that is angular and this is the linears. So now this is linear and angular kinematics for a particle in a circular motion. Let us consider one rigid body, that is the rigid body. This is let us consider one particle p in a rigid body, that is the distance of the r from through the axis of the through the origin point, that is OP is the r, that is the position vector, and rigid body is rotating in x axis xy plane, and this is the rotating the anti-clockwise direction. The rotation of the body, this is particle is moves in a circular of the radius is r antunam. If in rotating through the angle is the theta, this particle travels along the arc, the distance is the s. One particle is x axis lo rotate avutunnappudu, this particle is the displacement is s, angle is the theta, and radius is the position vector, that is the distance is r also. So here that is the angular displacement s is equal to r into theta. You know everyone, that is theta value, and theta is equal to s by r, s is equal to t into r. So here you can write theta is equal to s by r, and now s is equal to, you can r into theta, and differentiating with respect to t. So ds by dt is equal to r into d theta by dt. R is the constant, this is the distance of OP is equal to r. Here now we can write the above equation is what is ds by dt is equal to r into d theta by dt means that is omega, that is the angular velocity. Omega is equal to d theta by dt. So r into omega. Now we can write ds by dt means that is the displacement. Angular velocity is the rate of the change of the displacement, that is ds by dt is equal to v. You can write this ds by dt value in v. V is equal to r into omega, that is v is equal to r into omega. That is relation between the magnitude of the linear velocity and angular velocity. In differentiating in equation 1 with respect to t, we get dv by dt is equal to r into d omega by dt. Now dv by dt means that is acceleration. You know, the rate of the change of the velocity is called the acceleration. So that is dv by dt is equal to acceleration. So equal to r into, that is d omega by dt is the angular acceleration. So at equal to r into alpha. So that is the at means that is tangential component of the acceleration of the particle, and alpha is the angular acceleration of the rigid body. The radial component of the acceleration of a particle moving in a circular path is given by a r is equal to v square by r is equal to nt, that is v is equal to omega into r. You can substitute the value, that is omega square r square, r square is cancelled, that is omega square into r. You can write this v value omega square r square, that is r cancel, one is r is here, omega square into r, a r is equal to into omega square into r. So that is the radial component of the acceleration of the particle. You know, this is one particle is rotating anticlockwise, let us consider p, and this is the tangential component of the acceleration, and this is the radial component of the acceleration of the particle. So you can write this is the radial component of the acceleration is equal to omega square r, and tangential of the acceleration at equal to r alpha into r. So this is the ar and at. So relation between the linear and angular kinematics equations. Okay, thank you.